Okay, moving down from the head, the next major structure that's involved in the endocrine function is the thyroid. Now, if you didn't realize this already, I'll just reinforce that the models that we buy, of course, are not showing the symmetry of the body. And often you'll see on one half the superficial structures, on the other half deep structures. So the thyroid gland is actually bilobed. In other words, it has two lobes. This would have a mirror image on this side. As I said in the previous video, it would look like a bow tie. It sits just below the thyroid cartilage you'll learn about in the respiratory system, and technically the cricoid or cricoid cartilage here. So thyroid gland is a fairly small, important. The thyroid gland is going to be involved in controlling metabolism, and it also has a role in calcium, the levels of calcium in the blood, regulation of the levels of calcium in the blood. Okay, so we'll ask you, of course, in lab to identify that this is indeed the thyroid gland, whether it's on a model like this, or you can't see it on the sagittal head because here's the thyroid cartilage on this. So it would actually be right about here on this model, and it's been cut off. A number of our torsos show this, and I don't have any of those torsos here for the video today, but they also show the thyroid gland. Right? So the thyroid gland, again, this was targeted by the anterior pituitary hormone that was called appropriately thyroid stimulating hormone. And when thyroid stimulating hormone is released, it targets the thyroid gland, and the thyroid gland then begins to make two very important hormones that are very close chemically, called triiodothyronine and thyroxine. They're also abbreviated as T3 and T4, but of course as beginning students you've got to spell it out. You can't just give me that abbreviation. So T3, T4, the 3 and 4 represent the number of iodine atoms associated with the molecule itself. Okay, so thyroid gland making triiodothyronine and thyroxine, when these are produced, they increase the metabolic rate. So this metabolism is carried on by all cells in the body, so this really has a lot of targets. And so often I just tell students, just know that they're related to the process of metabolism. All right? And when there's low amounts of T3 and T4, then metabolism is lower. So this is another like growth hormone. As you study it, you realize that it has its largest effect is really on how we get energy and how we use that energy for either making ATP or for, in the case of growth hormone, making proteins. Right? Now, I said that the thyroid gland also has a role in calcium, regulating the level of calcium in the blood. So there's another hormone made here, so 3 in total, called calcitonin. And you see it in the name, calcium for calcium. So calcitonin made here is released when the levels of calcium in the blood become high. If they're too high, calcium levels have a homeostatic constant because calcium is involved in neuromuscular function, as you were introduced to in A&P1. So calcitonin is the answer to the problem of too high, right, where we're not in homeostasis with calcium levels. So if calcium levels go too high, calcitonin, as the blood circulates through the thyroid gland, these cells sense that, and calcitonin is released. All right? So calcitonin's targets, right, you've got to think, well, where would I go, or what would I want to influence, what stores calcium? And so the target's going to be the skeletal system. It also has a target with the kidneys as well, because kidneys influence the levels of all things in our blood. So when blood levels of calcium are too high, the cells here sense it, calcitonin is released, and that calcitonin then will, once it's released into the blood, like all good endocrine hormones, right, it then targets the bone in the body and causes bone to increase the activity of osteoblasts, because blast, B for builder. So osteoblasts become more active and they store, right? They remove the calcium from the blood and store it in the bone. So bone is built under the influence of calcitonin. This also can target the kidneys to cause the kidneys to release more calcium from the body in urine. So the amount of calcium in your urine is indicative of the state of calcium in your body. So when you have too much calcium in your body, well, one of the solutions to that problem is just to pee it away. And calcitonin is what tells the kidney then to do that. Now, if you look up here on the overhead projector, get this right for you guys so there's not glare. Get the sun. Oh, come on. Oh, darn it. Let me stop. Let's see if I can't play with the lighting a little bit for you guys. I was picking it up. We have a lot of problem with glare off of this screen and light of the day. All right. I can get a little bit of it. I just can't get it all on here. Like so you can see the upper parts of your field up here. All right. But so slides, you're going to have to know for lab the slides of the thyroid gland. And the thyroid gland is noted by all these circular structures made of simple epithelium. So we'll have to cover that in lab because I'm not really getting good video capture of the screen because of light bouncing, reflecting off, and the video, the camera picking that up. So we'll come back and take a look at the slides, but this is a slide that you are going to have to know for your practical purposes and will help you to understand a little bit more about the thyroid gland, which is again, involved in metabolic function and calcium regulation.